Again. All right, so today's Common Core standard really is the remainder theorem. Remainder theorem, because we are dividing polynomials. Okay, so if we're talking about the remainder theorem, the most important key to the remainder theorem is this. If it's zero, okay, the key is if it's zero. If the remainder is zero, it's a factor, okay? So I don't know if we want to write that on the side or up above, but let's write somewhere that if the remainder is zero, then it is a factor. Remainder 0 goes in evenly. If it goes in evenly, then it multiplies evenly, right? No remainder, right? So if the remainder is 0, then it is a factor, okay? All right, so let's look at example 1. Multiply and put in an expanded form, okay? So, yeah, we can do that. All right, let's multiply. Let's go this times this is x cubed. X times a negative 2x and negative 2x squared. X times a negative 8 is a negative 8x. Am I going too fast? Okay. Okay, and I'll multiply through by the negative 3 when you're ready, okay? I'll go negative 3 times x squared is a negative 3x squared. I'll do a negative 3 times a negative 2x is a positive 6x. Negative 3 times negative 8 is a positive 24. Of course, when I multiply, I like to line them up, right? Kenzie, you do that too, don't you? You like to line them up, don't you? I saw that you do that once, right? Line them up so we got the x's, cubes, and all that stuff together. So then I finally multiplied, okay? So then I've got a x a third minus 5x squared minus a 2x plus 24. Okay, that's my answer, okay? All right? So this is p of x now. So p of x in its expanded form is going to be here's p of x in the expanded form is going to be the x cubed minus 5x squared minus 2x minus 20 or plus 24. Thumbs up so far? I mean, we didn't do anything we've done before. We know how to multiply it, multiply it out. So pretty good. Emma, you're still looking. I'll wait for you, okay? Can you see okay? Okay. So then, let's take p of x, which is this, and divide it by x minus 3. Now, there's two ways to divide. One is that long way I showed you here 5 minutes ago. Or what's another way we could divide?
Synthetic division?
Why not? Will synthetic division work on this one?
Yes.
Yeah, so let's use synthetic division. So we're going to use synthetic because it's faster, right? It's easier. So we'll go 3 upside down, right? And we'll go 1, negative 5, negative 2, 24, right? Our addition line and a remainder, right? So far, so good? All right, so then we're going to bring down my first term. Bring it all the way down 1, right? 1 times 3 is 3. I add. Negative 5 times 3 is a negative 2. Multiply. Negative 2 times 3. Oh, yeah, if you were absent yesterday, Lachlan, you're going, what is he doing? But you'll catch on, right?
No, I think I got it. So
It's actually pretty easy, isn't it?
Yeah.
Negative 2 times 3 is a negative 6. Negative 2, negative 6 is a negative 8. Negative 3 times negative 8 is a negative 24. And the remainder is 0. It is 0. But I already knew that. You know why I knew that? How did I know the remainder is going to be 0 right off the bat? There's the original problem. There's the original problem. And there is the x minus 3 sitting right there. So I already knew it was a factor because to be a factor, it's something times something, right? So the remainder of 0 didn't surprise me at all, okay? So that means x minus 3 would pair up with a 1x squared minus a 2x minus 8. And that's what I had That's what I had right there. So what do you know? Of course it has to be a factor, right? It has to be a factor because I've got something times something, right? So there should be a remainder of 0 because we already know it works, right? Okay, now, find P of 3. Now P of 3, I already know the answer is going to be 0. How do I know the answer is going to be 0? P of 3, I know the answer. So if I do P of 3, I know the answer is going to be 0. How do I know that? I just divided it, right? I just divided by the 3 and I got a 0, so it should work. So let's give it a try. So I'm just going to prove what I already know, but I like to do that sometimes. Sometimes I like to prove the obvious so it gets into your head, right? Okay, so then if I go, all right, P of 3 is equal to my 3 cubed minus 5 times 3 squared minus 2 times my 3 plus 24. And go ahead and use a calculator, blah, 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 blah. But guess what? I already know it is 0. Okay, do you want me to do it? Want me to prove it to you? Sure, why not? Okay, so on the calculator you can see it. If I go 3 to the third power minus 5 times 3 squared minus 2 times 3 plus 24, and lo and behold, boom, it is 0! I already knew that, didn't I? Already knew that, huh? Okay, so then big deal. What about P of 4? What about P of 4? Let's see what P of 4 is. P of 4, let's see, that's going to be a 4 cubed minus a 5 times a 4 squared minus a 2 times a 4 plus a 24. Let's see about that one. Okay, I'm going to use my calculator because, I don't really want to do it by, the hard, long way. Why bother, right? So clear that. I'm going to go 4 cubed minus 5 times 4 squared minus 2 times 4 plus 24. Boom! Oh, I didn't like that. Go to it. What didn't it like? Oh, hold on. Try again. My bad. 4 to the third minus 5 times 4 squared minus 2 times 4 plus 24. Let's see what I get. Boom! 0! Whoa! Wait a minute! So that must mean that x minus 4 is also a factor. If P of 4 gives me a remainder of 0, then x minus 4 is a factor. Okay, let's check the next one. P of negative 2. P of negative 2, okay, is going to equal my negative 2 cubed minus my 5 times my negative 2 squared minus my 2 times my negative 2 plus my 24. Let's put that in my calculator one more time. Let's do one more. Slide it so we can see it. Clear that. All right, so I'm going to go parentheses. Negative 2 to the third power minus 5 times negative 2 squared minus 2 times negative 2 plus 24. Boom. Ooh, I get 0 again. Wow. What does that mean? That means that, you ready? That means that x plus 2 is also a factor. So hold on, wait. I'm gonna check something out. So if that's true, we know that x minus 3 is a factor, x minus 4 is a factor. So that means this polynomial here could have been factored into, you ready? This could have been factored into, you ready? An x minus 3 times an x minus 4 times an x plus 2. Wow. Now, I don't know about you, but that sure seems like a hard way to learn how to factor something, right? You agree? You agree? I mean, that's a hard way. Pick numbers, see if you get 0. Pick numbers, see if you get 0, right? That would be a hard way to factor. But if we do know how to factor, then it wouldn't be so hard. So, I think if I were to take a look at this piece right here, what would this factor into? What would this factor into? Wouldn't it be x minus 4, x plus 2? Wouldn't this? So if we had factored it right off the bat, we wouldn't have had to worry about doing it by synthetic division, getting a remainder of 0. So factoring, I know you thought you lost factoring. It's back. Factoring is back. Okay, example 3. if f of x equals x squared plus 2x minus 3 is 3 a factor, is 1 a factor? So there's two ways to do it. One is to factor it, right? Okay, so we could just factor it. You guys want to just factor it, or do you want to try synthetic substitution? So Savannah's, no, I want to do this. But if I plug in 3 and get 0, it's a factor. If I plug in 1 and get 0, it's a factor, right? So, but if it just factors, let's see what we got. Does this thing factor? Does f of x factor? Yeah? Yeah, does it factor? Leora says, yeah, I agree. What is it?
X minus 3 and x plus 1.
How about plus 3 minus 1, right?
Other than that.
Okay, you guys agree with that? And if we solve it and set it equal to 0, we get x equals negative 3 and x equals positive 1. Okay, those are the zeros. Okay, so real quickly, let me ask you an easy question. Is 3 a factor? No. No. Negative 3 is. So if we plugged in 3, I'm just going to do it real quick. Let's see what we get. Okay, if I plugged in 3 real quick, if I went parentheses 3 squared plus 2 times 3 minus 3, hey, I don't get 0. I get 12. If I get any answer with 0, it's not a factor. But we already knew this was not a factor. So 3 is not a factor, right? We know it for two reasons. One, if I plug it in, we don't get 0. Second reason, we factor it, right? Is 1 a factor? Yes. So I know that if I did f of 1, it would equal 0. Now I don't even have to plug it in. I don't have to do the calculator. I just know if I did f1, plug it in, I know I'd get a 0 because it's a factor. Do you think I've counted that through enough? Remainder of 0?
Factor.
Remainder of 0?
Factor.
Everybody, remainder of 0? Plug it in, you get a 0. What is it?
Factor.
What is a factor?
A factor.
Something times something without a remainder, maybe, huh? Okay, turn the page. So, all right, let's factor. Okay, hey, here's the same one we just did, right? So, Common Core, we are going to find factors by factoring. I know you guys, another one of those, that F word is back. Functions, fractions, factoring. All the good words in math start with F. Function, right? Fibonacci. So let's factor this. Boom, 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 boom. What do you get?
X plus 3 and x minus 1.
X plus 3, x minus 1. Those are its factors. So we know x plus 3 is a factor. We know x minus 1 is a factor. Capiche? That x plus 3 is a factor. X minus 1 is a factor, okay? Example 5. Does it factor? Yes. What's it factor into? What's it factor into? X minus 3 and x plus 3. Those are its factors, right, Emily? X minus 3 is a factor. X plus 3 is a factor. Something times something makes whatever. No remainder is a factor, okay? How about example 6? How do we factor? Okay, Alex, how do we factor? How you doing back there? Alex, how you doing back there? You good? All right, how do we factor this? What do you think? X squared. X squared. Nice job, Kenzie. Yes, and? Plus 9 and negative 9. Okay, now, this one's not done. It can be done again. Again. Well, we just did this one, didn't we? Didn't we just do this one? So this is a x plus 3, x minus 3, okay? What about this one? Can this be factored again? Please say no. This cannot be factored again. If you wanted to call it x plus 3, okay, on the sideboard, x squared. plus 9. Let's try it. X plus 3, x plus 3. Why is this wrong? Tell me, somebody tell me. Why is this not true? Yes, Caleb.
Because then it'll be x squared plus 9x plus 9.
There's going to be an x squared plus a 6x plus a 9 because you get your 3x and your 3x, right? That's what you meant to say.
Yeah.
I know you meant to say it. So this does not factor into this, right? Okay. So now, Sarah, we're almost done. What about this one? Okay, this one's called grouping. We're going to have to factor it twice. But to group, we're going to pair them up. Okay, watch. I don't think you've ever seen this before. Put these two together and these two together. Pair them up, okay? We're going to do by grouping, so we're going to pair them up, okay? So put the first two together, second two together, and we're going to common factor. So real quickly, everybody pair them up. Let's just ignore this for a second. Ignore it. What do these two have in common?
X squared.
So out of these two, let's take out an x squared. What it have left is an x minus 2, all right? Okay, so ignore this. They have an x squared in common. Common factor out an x squared, I have an x minus 2, okay? What do these two have in common?
-9.
A negative 9. If I took out a negative 9, I have an x minus 2, okay? Well, look at that. What do those two groups have in common?
X minus 2.
They've got an x minus 2. So if I factor out the x minus 2, what's left over? X squared minus 9. Can that be factored again? Now we're doing algebra 2 stuff. I like it. No more of that simple little algebra 1 stuff. Okay, now what? Can we factor that again? Sure we can. X plus 3, x minus 3. Those are its factors. Those are the factors. Those are all 3 of its factors. That hurt your head a little bit? Let's do one more, just because that one probably hurt your head a little bit, okay? All right. All right, let me put a 1 right here to make the next one a little bit easier. I'll put a 1 there because it's going to help you, okay? Put a 1 right there because it's going to help you, okay? So grouping. Put the first 2 together and the second 2 together, okay? So let's ignore. What do the first 2 have in common?
2.
X squared. Let's take out an x squared. So what's left over if I take out an x squared? What's left over if I take out a 2x plus 1? Okay? 2x plus 1. Okay, now, so we take out an x squared just out of the first 2. What about the second 2? What do they have in common? 4. 2 is yes, correct, but let's take out more. You're totally right. Let's take out more. Let's take out a 4. What's left over? If I take out a 4, what's left over? 2x plus 1, okay? Now, let's factor again. What do the 2 groups have in common?
2x plus 1.
They do. They've got a 2x plus 1. Take that out. What's left over? X squared plus 4. And that you cannot factor again. There it is. All right. Okay. I've got a page 433, 1 to 9 all. I sure will. And then I'm going to pass out in a